The next conic section, what we are going to understand and study is a parabola. Okay, now we are going to understand about parabola. Now, last year, you have at least learned, or maybe you would have plotted a parabola before. Okay, the quadratic equation, if you guys remember, the quadratic equation, you guys used to get a parabola. The up opening, side opening, down opening, you have learnt a lot of them. Now, let's understand what exactly is parabola. Okay, now, before you understand parabola, there are certain parameters what you have to understand. You know what defines a parabola. Clear? Now, for every parabola, to be honest, for every conic section, there is one fixed line, correct? There is one fixed line and there is one point which is moving with respect to this particular line. Even for a circle also, to be honest with you. Now, for a parabola, that fixed line what we have plays a very, very important part. Whereas for a circle, that line is not important. One point within the line is important. That's all. That's the difference. Okay, but you do have a line. Now, that particular line, you know, the fixed line what we have, that particular line is what we call as directrix. Okay, so again, I'll just write it down. That fixed line, or you can say that it's a fixed reference line. This fixed line is what we call as directrix. Okay, now for a particular line, fixed line directrix, there is one point which keeps on moving. Okay, it keeps on moving, moving, moving. That's how a figure is formed. The locus of a point which moves in such a way that it is equidistant from a line, that is the directrix, and from a fixed point. Okay, let me repeat this again. Suppose say you have a point. Okay, let's try to draw this one. Assume that we have a line something like this. You know, this is the directrix. And we have some point which is a fixed point. Assume that some fixed point is here. Okay. Now, for this fixed point, and we have a fixed line. Now, I have a point somewhere over here, or some point is there, which is moving in such a way that it is equidistant from the given line and from the fixed point. Now, that defines a particular shape, that defines a particular figure. That figure is what we call as a parabola. In the sense here, see, say I'm going to join this to this and from this to this. Perpendicular distance from the point and the line. Okay, not any other distance, always perpendicular. Now, in this case, let's say we'll mark the point. Say this point is P. Say this point is F. And say this point is some value A. Now, what we are saying is, we are saying PF is equal to PA. Okay, now the point P is moving in such a way that PF is equal to PA all the time, always. So, how can it move and what will be the shape of the figure? That's what we are trying to discuss now. Okay, and that shape becomes a parabola. Okay, so here, see the next point what you can do, let's say the point P comes somewhere over here. Okay, then it will come somewhere over here. Okay, so maybe that might not be the case. Maybe it can come somewhere over here, more like a midpoint. Then it keeps on going like this. See, something like this. And here also it moves like this, something like this. Okay, now if you join everything, so what you're going to get, if you keep on joining everything, see like this, keeps on going, it keeps on going like this. On this side, and in this side also, it keeps on going like this. You get a beautiful parabola. Okay, this is what you have plotted also, if you guys remember last year. So this is a parabola. It's a nice parabola. In such a way, so point moves in such a way that PF is equal to PA. Correct? All the time. Now that you know PF is equal to PA, what is that F? What is that P? And what is that A? Now that you have understood that the line what we have right now here, this particular line is what we call as the directrix. It's a fixed line, correct? We also have a fixed point F. That point is what we call as focus. It's the focus of a parabola. Fine. Now you have other points also. Like, see, how do we know it's always moving? So if you take this one, see this distance and this distance, they are one and the same. Come here, come here. They are one and the same. So it's always the same, and it's always going to be same for a parabola. Now, see, there is one point which is the lowest point of this parabola. Right, the lowest point of the parabola, this point, we call this as vertex of the parabola. This is called vertex of a parabola. Now, there are three important parameters which is going to define a parabola. Directrix, the line, focus, the fixed point, third point is the vertex. Now, these three parameters, they define how the parabola looks like. If the fixed point, that is the focus and the directrix, is very far away, depending on how the locus of the point is moving, you are going to get a different type and shape of a particular parabola. Okay. See, we are discussing a lot about what is a parabola and how a parabola is created from a moving point. Now, the next thing is we are going to understand about the equation of a parabola. Okay. Now, technically there are two equations and the other two are just mirror images of them. Okay. So, we'll discuss one equation of the parabola and we'll look into the other parts as to how they look like and what exactly is the equation of those two. We'll look into all those things. All right. So let's start with the first type of parabola now. The first type of parabola, what we are going to look at, see here we are going to have a directrix. Okay, this is directrix. Now, what we'll do, we'll look into the directrix as some line, say x is equal to a. Okay, some line x is equal to a. Now, we have a fixed point. Let's assume that the fixed point is on the x-axis. In the sense, a focus is here, which is a comma 0. Okay. So, here, since we are taking x is equal to a, I think it might have to pass through a comma 0. So, what we'll do, we'll change the equation of the directrix. Let's make it as x is equal to minus a. Okay, x is equal to minus a. That means in between these 2 points, we have the origin somewhere here, which is exactly in between. So this is the origin O. Okay. Now the locus of a point which moves in such a way that I'll take the point, say this point is F and some other point here is A. Okay. Now you have some equation which is moving like this. Okay, this is the parabola. Now the parabola moves in such a way that from P to A distance and P to F distance, these two should be the same, isn't it? So let P be some point x comma y. So P be x comma y. Now A is a comma 0, isn't it? Now we have the perpendicular distance. Now we can write PA is equal to PF. PA, you can see, for to calculate the PA value, we'll have to adjust a little bit here. Okay, we'll look into that. But PF is very easy because P is x comma y, F is a comma 0. Very easily you guys will get the value. Correct? But here, A value also we can calculate very easily. See, this point A, the coordinates of A is going to become minus A because it's in x is equal to minus A. And see, P is what? X comma y, right? That means if P and A, it's a perpendicular line. That means the y coordinate should be the same. So minus A comma y. This is PA. And PF is going to become this. Make sense? Now, in this case, what we are going to do now, what we'll look into it is the parabola is moving like this and PA is equal to PF. So, when you take PA, The distance, normal distance formula, nothing else. X plus a whole square plus y minus y whole square is equal to PF. So PF is going to become root of this is equal to root of x minus a whole square plus y square, because y minus 0 whole square, right? So it's just y square. Square on both the sides. The root gets cancelled. You get x square plus a square plus 2ax, y minus y is 0 anyway, is equal to x square plus a square minus 2ax plus y square. Correct? X square cancels, a square cancels. Now what do you get here? Y square is the subject. Make y square a subject of formula. You get y square is equal to 4ax. So y square is equal to 4ax is the equation of a parabola. Okay. Now this is the equation of a parabola, but that too, this is a right opening parabola. If you look at this, it's a right opening. Likewise, we have 4 types of parabola. Depending on the opening, the equation is going to change. We'll discuss about that now. First one you guys just saw. That is, see here. So it's going to be like this. A right opening parabola, you get y square is equal to 4ax. Okay, the first type. The second type, which is also very popular, is something like this, which is x square is equal to 4ay. This is origin. Clear? Next, third one, the same thing but in the opposite direction. See like this. Y square is equal to minus 4ax, and the last one, the fourth one, you are going to have down opening parabola. X square is equal to minus 4ay. Now these are the 4 types of parabolas what you have, and if you look at it, depending on how the parabola looks like, the equation of the parabola is going to change. Now remember, in the derivation what we just did, if you go back and if you look at the video, the parabola is not passing through the origin, it is passing through some other point here. Correct? It's not passing through origin. So technically y square is equal to 4ax will not be the correct equation. Okay. Now here and there I made some small changes so that you guys can look into it. But actually speaking, the equation becomes y square is equal to 4a into x minus h for that one. Okay, now how we are going to get that h and k and everything? All these, calculating the vertex, calculating the center, center in the sense the focus, calculating the directrix, all these things, and also there are certain parameters. You guys are going to learn about these things in the upcoming videos.